We're used to a specific sequence when designing a product. You sketch a form, figure out materials, and find out what it costs. But looking at 4 major announcements this past month, that sequence has shattered. All 4 share the exact same deciding metric. And in none of these cases is that number a structural load, a financial budget, or a physical dimension. It is a rate. Specifically, the rate at which a part leaves the tool. We are looking at a system where the speed of production is selecting the base materials, and through those materials, dictating exactly how complex a geometry can even exist, well before anyone breaks ground on a factory. Cycle time has effectively moved off the manufacturing floor and planted itself right at the top of the design brief. Long before a human draws a single line, the clock is already making the most crucial decisions. Take Yamaha. They just rolled out a mandate for their new outboard motors. This chart shows their core objective, a strict 20% cut in molding cycle time. To hit that target, they adopted a high-cycle sheet molding compound. Normally, you specify SMC for its stiffness and dimensional stability. Here, it was chosen explicitly for how fast it cures and releases from the press. That single choice cascades down into the physical reality of the product: the cowling's surface texture, the draft angles required to pull it from the mold, and the economics of how it gets repaired. All of those parameters are forced by a decision made on a stopwatch. We see the exact same math working on construction sites with Gyproc's new hybrid stud. Here, the production rate actively overrides the cost of base materials. The product is essentially 2 wooden mini studs joined by a metal bracket. Moving to wood means the raw material price roughly doubles compared to a traditional steel stud. But it ships flat, folds on site, and cuts the installation time in half. The mechanics of how it gets attached dictate the schedule. Because the fixing now lands in softwood rather than hard steel, a staple gun replaces a screw gun, and the whole program accelerates. The unit cost went up, yet the total job got cheaper. A minor fastening detail single-handedly shrunk the construction timeline. This kind of constraint also locks in the final look of a product. BMW recently integrated B-Comp's Flax composite on M-Series ground effects and roof panels. They chose it because it drops production emissions by up to 75%. To prove just how absolute this system is, look at its exact inverse. Over at Pre-Lab Design Studio in Hyderabad, they are removing the industrial machine entirely. They are running algorithmically complex computational geometry through hand-woven wicker, explicitly to see what forms they can realize without standard industrial infrastructure. Take a look at this scatter plot comparing the 2 economies. On the left, injection molding requires low complexity to churn out high quantities. With wicker, the constraint of cycle time is gone. Structural complexity becomes free, but mass quantity becomes prohibitively expensive. It's the same lever pulled in the opposite direction. As a creator, you have to know explicitly which of these 2 economies your concept is actually being drawn for. The modern chain of production is unforgiving. The rate picks the material picks the finish, and the finish is the only part of the chain the customer ever actually sees. This is where standard generative AI models run into a wall. They are inherently built to surprise you, which means by default, they drift away from physical reality. In professional design, novelty is just a demo. Unyielding consistency is the actual product. You have to be able to accurately predict the physical state of a manufactured object, down to the flash at the edges and the exact heat radiating off a freshly molded panel, while it is still nothing more than a digital concept. Because altering a design decision is practically free during the sketch phase, but brutal on the balance sheet once a factory tool is actually cut. You need intelligent systems built to see every possible angle before anyone gives the order to start building.